Hi, myself Saurabh Noskor, Assistant Professor of Chemistry at Gargi Memorial Institute of Technology. In my previous lecture, I discussed about first part of thermodynamics. Today I will discuss second part of thermodynamics. I will start with reversible process. See, reversible process is a process which can happen in both the direction. Means here both forward direction and backward direction is possible, so formation of B and A will also be possible. And irreversible process means a process which can happen in single direction. Here only forward direction is possible, and here formation of only B is possible. Work done in reversible process is equal to nRT ln V2 by V1. This is the formula for work done in reversible process. Here N is number of moles of gas, R is universal gas constant, T is absolute temperature, V2 means final volume, and V1 means initial volume. Is equal to nRT ln P1 by P2. You can write V2 by V1 or P1 by P2. You all know volume is inversely proportional to pressure. And work done in irreversible process is equal to P external V2 minus V1. This is external process, external pressure, and this is final volume, this is initial volume. So you have to remember two formula for work done in reversible process and irreversible process. Now we have to compare the PV curve of isothermal process and adiabatic process. This is the PV curve for isothermal process and this is for adiabatic process. See, this is less steeper and this is more steeper. And less steeper means slope will be low in case of isothermal process, and in adiabatic process slope will be high because this is more steeper. Now we have to solve a question of thermodynamics. All the adiabatic reversible expansion led to a fall of temperature. Fall of temperature means there will be cooling, means decrease in temperature we have to justify. Adiabatic process means Q should be 0 because in between system and surrounding no heat will be transferred. So from first law of thermodynamics, this is first law of thermodynamics, here we will put 0 for adiabatic process, so del U equal to minus of W will be there. Now we can write differential form. Differential form means you have to write du and dw here. Now du, change in internal energy, is equal to NCV dt. NCV dt, N is number of moles of gas, CV means molar heat capacity at constant volume, and this is change in temperature. So du is equal to NCV dt, and in place of dw we can write pdv because this is the formula for work done. Now in place of P again we replace it with nRT by V because you all know PV is equal to nRT. So now integrating left hand side between T1 to T2, this one, and right hand side we have to integrate between V1 to V2. So this T will come in this side, this one, and here minus nR will be there, and integration dV by V will be there. On integrating, this will comes out ln T2 by T1, and this will comes out ln V2 by V1. Now we can cancel both n in the both side. This 2n will be cancelled, and this again we can divide all the term by CV. So if you divide CV by CV, there will be 1. So only ln T2 by T1 will be in this side, and here n will not present there. R by CV will be there because we are dividing all the term with CV. R by CV and ln V2 by V1. This is the equation for Cp minus Cv is equal to R. Cp means molar heat capacity at constant pressure. This is molar heat capacity at constant volume. I will discuss in the next page, and I will also derive this equation also in the next page. Now we can divide all the term by Cv. So Cp by Cv, Cv by Cv and R by Cv. This Cp by Cv will be gamma, Cv by Cv will be 1 and this will be R by Cv. So in place of R by Cv we can write gamma minus 1 and this minus become plus because we interchange their position V2 by V1 and here we change the position V1 to V2. So now this term will go in the power of this one. Both ln and ln will cancel out. So we can write T2 by T1 is equal to V1 by V2 and V1 to the power gamma minus 1 and the below side V2 to the power gamma minus 1 and this gamma is always greater than 1 and V2 will be greater than V1 because expansion happens here. Expansion means final volume will be larger than initial volume. So if you put this value here, it will comes out that T2 will be lower than T1 and T2 lower means final temperature lower. Final temperature lower means there will be fall of temperature, means cooling will be there. Now heat capacity. Heat capacity is molar heat capacity is denoted by C. This is the amount of heat required to raise the temperature of 1 mole of substance by 1 Kelvin. So amount of heat required to raise the temperature of 1 mole of substance by 1 Kelvin. So C is equal to dQ by dt. This is heat and this is temperature. There are two types of molar heat capacity. First one is Cp, second one is Cv. Cp means molar heat capacity at constant pressure and this is molar heat capacity at constant volume. So we can Cp means there will be dQ by dt at P will be there, this one. And we all know heat at constant pressure is equal to change in enthalpy. So we can write in place of del Q, we can write del H. So we can write dH is equal to Cp multiplied by dt, this one. We can replace d by delta also. So we can write del H is equal to Cp of del T. Del T means change in temperature, this is change in enthalpy and this is also final temperature and initial temperature, this one. This is applicable for 1 mole of gas. And Cv means there will be Cv means del Q by del T at constant volume and heat at constant volume is equal to change in internal energy. So we can write del U by del T at V here. So we can write du is equal to Cv dt. Now we can change d by del. So del U will be equal to Cv del T, this one. And del T means final temperature minus initial temperature. This is also applicable for 1 mole of gas. Now limitation of first law of thermodynamics. It does not indicate the direction and extent of change. Second, it does not give any idea about the source of heat, randomness of a system and the spontaneity of a system. In order to overcome this problem, we need second law. Second law gives explanation upon the direction of heat transfer and it gives concept of entropy and spontaneity of the system. Now one MCQ question is there. Standard molar enthalpy of formation of any substance which is present in its standard state means oxygen or hydrogen or nitrogen or chlorine gas will be always 0. And when an ideal gas expands spontaneously into a vacuum, when a gas expands in vacuum, then always work done will be 0. So that Cp minus Cv is equal to R. We all know from thermodynamics equation Cp minus Cv is equal to T del P by del T at V del V by del T at P. Now for ideal gas, 1 mole of ideal gas Pv is equal to RT. So we can write P equal to RT by V or we can write V equal to RT by P. Now when this T will come below side, so del P by del T at V we can write R by V. And del V by, when this T will come in below side, so we can write del V by del T at P will be R by P. So in place of del P by del T at V, we can write R by V. And in place of del V by del T by P, we can write R by P. So R will come this side, T will go there. So there will be RT by PV and RT by PV is equal to 1. So Cp minus Cv is equal to R, proved. See, PV is equal to RT, so PV by RT will be 1. Thank you. In my next lecture, I will continue this thermodynamics.